All right, guys, let's continue. Apologies about that. Where were we? I think we were done with what were we done with? We were done with search as well. If I'm not wrong. Hmm. All right, let's see what's up. Hmm. So the last thing that we did was search, and we've done that. Anyone has, if there's any questions from anyone, kindly do let me know as well. Hmm. If not, we'll continue. Assalamu alaikum, Ishal. How are you? And Assalamu alaikum, Basit. How are you? Hello, can you guys hear me?
Walaikum salam, sir.
Yes. Basit. Hmm. Also, when you guys join in the class, is there an issue with joining in today? Hmm? Like, are you having trouble joining in class today or no? Because sometimes, I don't know why, ever since I started the recording, the meeting is glitchy all of a sudden. But we don't really care. Let's continue. We've done indices. Now let's start off with what you may call, let's do standard form. All right. In today's class, let's discover standard form. Just give me a moment, I'll begin. So,
Sir, for surge, will we learn about the rationalization where, we take the opposite sign when we are like multiplying it and we do all of that? Are we going to learn that later?
yeah, when I've, Zoya, right?
Yes, sir.
Yeah. Yeah, Zoya. So what we do is that I think I've told you guys this before as well, that I am going to, switch up the syllabus along as well. So any of those questions, and that the topic that you're referring to, it's not entirely another topic. Like it's not another topic, it's just one type of questions that come, when you're flipping the sign. I get what you're saying. We usually at your level we don't say that, but usually in A levels that we call them in like conjugate bases and stuff of that sort, where you flip the sign when the rationalization occurs. All right. So when we do questions regarding that, we'll go through with it as well, because that is going to be much more useful when we do questions. And I don't want to do individual questions of those. I would want you guys to do a few topics together, and then we can do the questions. All right. Yeah.
All right.
Hmm. All right. Let's do standard form today. Just give me a moment, guys. Just give me a moment, guys. Yes, guys, apologies about that. Let's begin. So where were we? What did we were? What were we about to begin? Standard form. I'm going to do that. Hmm. All right. So now we're going to try and continue with this. Yes. So as we begin with standard form, it's whatever we've studied above or whatever rules we've studied above, they're going to apply to this. It's just simply going to be, an application of what we studied. It's not that difficult. It's one of the more easier topics that we have. So, for example, you know, if I were to describe what standard form is, it's you can say more or less um, a one way of expressing something, which is, of expressing something in powers. And if I were to, very simply put it, like as to how you're going to express something, it's just going to be that, you express any number, any value, or any number in powers of 10. Or you can say using powers of 10. What do we mean by that? Let's see. So, for example, what's going to happen is that whenever you have any sort of, if I were to display this in a general way, it would be, any number, and you're displaying it or you're expressing the entire number in powers of it, using powers of 10, not 10 as a power. A lot of students get this confused for some reason, that they think that whatever number you're taking, you're going to take the power as 10. No, that's not the case. You multiply it with 10, and 10 has some sort of power. All right. So this is how uh, this goes. It's pretty simple, that obviously, because we're taking powers of 10 to express that number is not very, you can say, a very conventional or a very normal number. Now, there can be two instances when you use powers of 10. Obviously, what are those two instances? That's simply what you're going to have is that either the number is way too large, or either the number is way too big. But one thing that you need to know is that this number, it's always written like this. Whatever number that you may have, it's a number, then there's a decimal, and there's always a single digit number before the decimal. Whenever you're trying to write something in standard form, you're going to have to write it just a single, what you can call, there's a single digit number, and then your decimal begins if there are further numbers. Like, for example, um, whatever it is, any number, could it be like, if it's like 2.42 times 10 raised to the power something. So that's also written in standard form. How do I know that? Because there is only a single digit before the decimal. There's just one digit before the decimal, and that number is always going to be a single digit number. That cannot be a number which is greater than, or you can say 9 or less than 1. All right. And we're not usually, we never really cater to negative numbers as well when we're going for standard form. That's something extraordinary. We don't do that. And what we do cater to is that your a, the constant, the variable a I've used is that it's, if I were to explain what it is, it's just a single digit number before the decimal. So it's just a single digit number before the decimal. After the decimal, you can have countless numbers. Usually they're, the examiner says to write them down up to 3 decimal places. So we normally stick to that. Now, I've told you that because you're using powers of 10 now, obviously powers of 10, whatever they may be, and then your whatever answer you're getting using that powers of 10, you're multiplying it with your number. So obviously that means that either your numbers, obviously it's unusual. It's unusual in the sense that you cannot express it in its own natural form. You cannot express it as a power of itself or something of that sort because it's highly unusual. How do we know that it's highly unusual? Because you're using these powers of 10 and stuff of that sort. So now, for a number to be unusual, we normally have sort of like two scenarios that we cater to when we say that a number is unusual. What are those? Is that first off, either the number is way too big. All right. Like, for example, the number is way too huge for you to consider it, to write it down. All right. Like, let's just say that, it's in millions and stuff of that sort, and there's a lot of repeated numbers as well, or whatever it is. It's a very big number. So we can just, write it down in like a shorter, abbreviated version of itself by using powers of 10. We can do that. Or maybe the opposite can happen as well. The number is way too small, like it's 0.000 and, like 2, 3, or something of that sort, whatever it is. So that number is either way too big or way too small. That is why we're using powers of 10 in order to, sort of like magnify it. We're trying to go to the actual number rather than the entire width of that number. It's in like if it's in millions or something of that sort. When that is the case, you're going to have two scenarios as well. What are those two scenarios? Over here, you guys can clearly see that the power I've not identified as well. It could be any power that there is. Now, the power is a positive number or it's greater than zero, which is just simply, saying that it's positive. The power is positive. When? When do we use a positive power for 10 when writing in standard form? That is used for extremely large numbers. For large numbers. Now, there can only be two instances, right? Obviously, the power is not going to be zero. Because if the power of 10 is equal to zero, that just means that you're multiplying whatever it is with one. We've studied that before. Now, what's going to happen is that if x is greater than zero, it's obviously it cannot be zero. So it's either going to be positive or negative. So if it's positive, that means you're using a larger power of x. It's a positive power of x. That means it's going to be used. Your actual shape of your number is actually it's very big. Secondly, what if your it's what you may call a negative number. Clear? What if it's a negative number like this? And obviously, if when the power is positive, we use it for larger numbers, and when the power is negative, we use it for s- it's going to be obviously the inverse of it. So we're going to use it for smaller numbers. So for smaller number, all right. Just give me a moment. All right. So now what's going to happen is that obviously we already know that if the power is a positive number, it's going to be for larger numbers, and if the power is a negative number, it's for smaller numbers as well. Why is that the case? Let's see. So we've studied these rules above as well for indices and surds, and we're going to apply them. But first of all, we need to, mm, dial it down a bit. How do we dial it down? If I multiply anything by 10, where does the decimal move? Yes, Hayan, if I multiply anything by 10, where does the decimal move? Yes, Hayan, can you hear me? Hello, Hayan, can you hear me? I cannot hear Hayan if you're saying something. Yes, Basit, what happens? If I multiply anything with 10, where does the decimal move?
Forward.
Forward where? Like above? Basit, be less cryptic, please. Tell me, Basit, come on. Leftward, rightward.
Rightwards.
All right, Basit. So the decimal moves, like Basit said, forward, but Basit has really bad sense of direction. So what he meant was that the decimal moves to the right. And how many, technically, we should say, is that if you multiply anything with multiples of 10, so multiply anything by multiples of 10, then the decimal moves to the right. This is like a tongue twister. Multiples of 10. The decimal moves to the right. And how many places does it move? It moves the number of places uh, amounting to the number of zeros there are. And if the same thing happens, that if you divide anything by 10, obviously the inverse, the opposite of it is going to happen. So the decimal is going to move, or Bassett would have said that it moves to the left, but clearly it would have moved. Oh, Bassett would have said that it moved backwards, but what he meant to say was that the decimal moves to the left. Whenever you multiply or whenever you divide by multiples of 10, you see movement from the decimal itself. Okay. Also, we already know this. This is like predetermined information to us. What's going to be more interesting is that I'm going to take this guy now. Let's just, take him down and get to him. So, for example, we're going to be what if x is a positive number? So, if x is a positive number, we also know that, for example, if x is, any positive number, We know that it's just simply going to be 10 raised to the power x if you're considering this guy. But at the same time, x can be negative as well. So if x is a negative number, what is what is going to happen? So it's going to be 10 raised to the power negative x. And we've already studied from rules of indices that if there's a negative power, you take reciprocal. Now, considering these two, what can we do is that if I look at it from a further point of view, it's going to be a times 10 raised to the power x. And over here, it's going to be slightly more different. It's going to be, what will it be? So it's going to be what you may call a times 1 over 10 to raised to the power x, which can also be written as a over 10 raised to the power x. Now, the entire reason behind proving this point is that when we said that x as a negative power or the power above 10 is a negative number, when we say that and we say that it's used for smaller numbers, that is true because technically this is what's happening in the background. Whenever you use x, whenever there's a negative power of x, that means that you're dividing it with, you can say, powers of 10. So what is going to happen? That number originally was smaller. We wrote it as a standard form. That number originally was a very small number. Why? Because you're now dividing it with um, powers of 10. So that means whenever you're dividing with multiples of 10, the decimal moves to the left. So because of this reason, your original sort of what you can say number is actually pretty small, because if you actually divide it with 10 and not write it in this form, the original form is somewhat a smaller decimal number because you're dividing it with 10. And obviously, the greater the denominator, the smaller the number. Whereas if x was taken as a positive power, that is for larger numbers. And how do we know that? Because it's simply you're multiplying with the positive powers of 10. So obviously, it was a very large number. That is why we wrote it as an alternative form. This is an alternative form of that same exact large number. And what is that alternative form? That it's just going to be a times 10 raised to the power x. Is this clear? Any issues with this? So, for example, if I were to, let's do an example. So let's just say that 0.00173. Okay. Question not written like this. Usually the question comes like this, like write this in standard form. This is also, I would say that it's much more, this type of question, these type of questions do lean towards paper two much more than paper four, but it's not as if they cannot come in paper four, because this is something that, you can do it both ways. So write in standard form. That is like usually how your question does seem to look like. And I'm talking about one of the, the easier ones. Like obviously the difficulty level is going to be far more greater than the example I've given. But let's just see how we do it. So first off, let's write it down and see. So it's 0.00173, and I want to write it in standard form. Now, in order to write it in standard form, I already know how it's going to look like. How do I know how it's going to look like? Let's just see that I know that in order to write standard form, I need a single digit before the what you may call the decimal, and that single digit cannot be less than one. All right, so that single digit cannot be. So technically, I cannot write it like 0.173. No, I cannot do that. I need it to be, my standard form needs to be 1.73. And obviously, you can write excessive zeros or you cannot, it doesn't really matter. Times 10 raised to the power some value. All right, what value is that? We don't know. That is what we're here to find out. So I know the final look is going to look like this, but I just don't know how to get to this look. Now, Because this is a smaller number that we're writing in standard form, I know one more thing, that whatever my power is, it's just going to be negative. That is just, without even solving the question, that is just by looking at the question, I've derived all of this information. Now, let's use this information. In order to move the decimal to this point, I need my decimal, which is what you may call over here 0.00173. That's where my decimal is. And in order to move my decimal to this position, I need it right here. Well, let me write it down a bit more with spaces so better to understand. So now I want my decimal to be here, right? That's where my decimal should be, decimal point should be, in order to make sure that I'm writing it in standard form. So technically, what I need is that I need some sort of movement from this point forward, and it needs to go like this, it needs to go like this, and it needs to end up over here. Well, that is what it made up. So it needs to go like this, and go like this. Clear? And it needs to end up over here. So technically, how many places I'm moving? I'm moving one, two, and three places. Clear? I'm moving one, two, and three places. And because I'm moving three places, we've already established that when the decimal moves when you divide or multiply with multiples of 10. And how many places does it move? The the number of zeros of the 10 is going to have. And how we're going to determine that is that we're going to determine what sort of power 10 is going to have. And that is going to be determined by the movement. So I've moved how many places? One, two, and three. So what should be my power of 10 looking like? Yes. Yes, Zoya. What do you think?
1.73 times 10 power another 3.
Minus 3, yes. You're absolutely right there. So it's going to be 1.73 into 10. And I already know that it's a minus. I just need to know how many, this power actually tells you how many decimal places you've moved. Because 10 raised to the power 1 means you've moved one decimal place. 2 means you've moved two decimal place. Why? Because 10 squared is 100. And I've told you that when you divide or multiply with multiples of 10, you move the decimal according to the number of zeros that you may have. Clear? So it's going to be 10 raised to the power minus 3. Is this clear? And that will be your answer for this if you're trying to solve it. All right. Any issues with this, guys? Is this clear? All right. Keeping this in mind, let's move on. And now we're going to see how to do addition and subtraction using what you may call standard form. Okay, let's just do a question with the larger number as well first, just to clear it up. So I'll use the same example. 173, like four zeros or something like that. Just making these up. These are not past paper examples. So, oh, wait. Now, if I were to, okay, do this one. If I want you guys to do this one, let me know when you're done. Whoever does it first, let me know so that I can share whatever you've done with the class. It's really easy, guys. And also do avoid using your calculator because this is not a question that needs to be done with the calculator. Yes, that was quite.
1.73 multiplied by 10 to the power 6.
Uh, 1.73 into.
multiplied by 10 to the power 6.
Okay, okay. Wait. You guys saw this telling us that it is 1.73 into 10 raised to the power 6. Who agrees with him? Yes, Raneem and Honey and Hamdan. Do you guys have
Yes,
the
sir,
same
I got
answer?
the same answer.
All right, Honey. Thank you. And everyone else has the same answer. Hayan, did you not get the same answer? Where did Hayan go? Hayan, can you hear me? And Basir, did you get the same answer as well?
Yes, sir.
All right. This is like extremely easy. And yes, I think you're right. Let me check as well. So technically, we already knew just by looking at the question that you're going to have a positive power of x. Oh, positive power of 10. So one, two, three, four, five, six. Six places you needed to jump. No. Let's continue with this forward. Now let's look at your addition and subtraction of your what you may call powers. Oh, standard forms. So when we're looking at addition and subtraction of standard form, but there's a catch to it. This is also subdivided into two topics. It is subdivided into two topics, such as you're going to have two cases now. What is that? That first off, addition and subtraction for equal powers of 10. What if you're given a question in which you're given equal powers of 10? Then you're going to do it differently, slightly differently than when you're given unequal powers of 10. So for equal powers of 10. And what do I mean by equal powers of 10? Is that whatever two numbers written in standard form you're adding or subtracting, they both have the same power of 10. So for equal powers of 10. Now let's see what does that do to us. First off, it's fairly simple. This is like extremely simple. When the powers are equal for both, like for example, I can say that a, and this is a decimal, and obviously numbers can follow after this. So a times 10 raised to the power x um plus or minus whatever it is. So plus minus b times 10 raised to the power x. Now you guys can notice that both the powers of 10 are equal. So what you're going to have is it's fairly simple. It's going to be a plus b times 10 raised to the power x. So technically I just took them common because they both were multiplying with it. Like for it's the same thing, like if it was written like this, ax plus bx. So I took x out as common and a b just added together. That's the thing only I did. So you add or subtract your individual standard forms by themselves and you just multiply with the same power of 10. Clear? This is not difficult at all. If we get to a question, it can be anything, and make it up on the spot, like 1.73 into 10 raised to the power 6. We can do that. Or what was the other guy? Um, oh, it's the same thing. So you add it into 2.7 or something like that into 10 raised to the power 6. So simply what we're going to have is that we're just going to add these two guys together and we're going to get 1.73 plus 2.7 and you're just going to multiply this with 10 raised to the power 6. All right, whatever answer you get with for 1.73 and 2.7, I don't really care. But there's a slight catch. Whatever answer you get, like, okay, This is easy in the sense that, you're probably going to get, what are you getting, by the way, for this? You're getting like, I don't know, like 4.43 or something like that. Not sure though. Whatever it is. Now, for example, if it says, usually these type of questions say at the end that, write your answer in standard form. All right. This is a key statement of the question that they usually mention is that, write your answers in standard form. So write the answer in standard form. What do they mean by this is that, usually what happens is that what if your sort of like rules of standard form are not being obeyed when you're solving this. So, for example, write your answer in standard form. What do I mean by that? Let's see. So, for example, I'll just do an easy one. 9 times 10 raised to the power 3 plus 2 times 10 raised to the power 3. Now, these answers are in standard form because they're 9.0 and 10, 2.0. But my final answer is going to be what? 9 plus 2 and times 10 raised to the power 3, which is going to be 11 times 10 raised to the power 3. But this is not the right answer. Why? Because this is not in standard form. In order for standard form to exist, we need my number it should be a single digit number before the decimal. So you're even going to convert this. And how will I convert this? Yes, can anyone tell me how will I turn this into standard form? Keeping in mind that I'm moving the decimal over here. It's a larger number. I'm making it smaller. So what should be the difference? Yes, please. Yes. Who's going to tell me what is the standard form of this number? How do I
1 multiplied by 10 to the power 4.
mm, easy? All right, so this can happen as well. Make sure that your final answer, if it's stated in the question, which it usually is, make sure that it's in powers of um 10. Oh, in powers of 10, and it's also in standard form. Clear? Now let's look at, for example, what if you're doing addition and subtraction, but it's for unequal powers of 10? For unequal powers of 10. So what is it going to be? You're simply going to have, what is that now this time around, you're going to have to um, try and make the powers of 10 equal before you start adding or subtracting. So what we do is the first step. Oh, just give me a moment, guys. So first off, you're going to make your powers, or you convert your power equal to each other. So that's the first step. So whatever your standard forms are, if they have unequal powers of 10, convert the standard forms, convert the standard forms into equal powers of 10, into equal powers of 10. And how you're going to do that is pretty simple. Equal powers of 10. Just give me a moment. Something's going crazy. All right. So we are going to try and see how to convert the standard forms into equal powers of 10. But that's what we're going to try and do in the next class. All right. So we'll stay tuned till then because I have another class after this. So Allah Hafiz, everyone. Keep smiling. Have a nice week, guys. I'll see you on Monday. Bye bye.
Love.
Allah Hafiz, Allah Hafiz.
Love is
Allah Hafiz.